So independence. So here two events A and B have non-zero probability of occurrence. That is, probability of A is not equal to 0, probability of B is not equal to 0. So if this probability is not equal to 0, then these two events have non-zero probability of occurrence. Okay. So we call the events statistically independent events if the probability of occurrence of one event is not affected by the occurrence of other. So then we say that these two events are statistically independent. Okay. So when we say that the two events are statistically independent, so we say that these two events are statistically independent if the probability of occurrence of one event is not affected by the occurrence of other event. Then we say that these two events are statistically independent. Okay. So if two events are statistically independent, in that case, so probability of A given B is given as probability of A and probability of B given A is given as probability of B, because the occurrence of one event does not affect the occurrence of other event. So there is no conditional occurrence between two events. Okay, that is why probability of A given B is equal to probability of A, probability of B given A is equal to probability of B. Okay, so if these two equations are satisfied, then we say that the events are statistically independent. Okay, so if you take any one of this event, if these conditions are satisfied, then we say that these events are statistically independent. Okay, so here, for example, independence also means that the probability of joint occurrence of two two events must equal the product of two events probabilities. Okay, so that is probability of A intersection B should be equal to what? Probability of A into probability of B. Okay, so we have discussed these equations. The condition 1, 2, 3. No, so in these conditions, either of this equation 1 or 2 or 3. So either of these equations should be satisfied. If these equations are satisfied, then we say that the events are statistically independent. Okay. So here this equation 3 particularly is used to test the independence. Okay. If this equation is satisfied, then we say that these two events are statistically independent. Okay. So equation 3 is served as test of independence. Okay. So usually equation 3 we use to test the independence. Okay. So then here we already discussed that if two events are mutually exclusive, we know that probability of A intersection B, okay, probability of A intersection B is equal to 0. Okay, so from equation 3 also we have discussed that for independent event, probability of A intersection B should be equal to what? For independent event, probability of A intersection B should be equal to what? It should be equal to probability of A into probability of B. If the two events are mutually exclusive, then what is probability of A intersection B is equal to 0. Okay. So from these two conditions, we can say that if two events are mutually exclusive, then they cannot be independent. Okay. So either of these two conditions should be satisfied. Okay. Either the two events should be mutually exclusive or the two events should be statistically independent. Okay. So in these two events cannot be both mutually exclusive and statistically independent. Okay. So in order for the two events to be independent, if you want two events to be independent, their intersection should not be equal to null set. Okay. So it means that the A intersection B should not be equal to null set, means they should not be mutually exclusive. Okay. So if the events to be independent, the events cannot be mutually exclusive. If the events are mutually exclusive, then they cannot be independent. Okay. So whenever we want to check the independence by pair, we'll be using either equation 3 or 1. So what is equation 3? Equation 3 is probability of A intersection B should be equal to probability of A into probability of B, or equation 1. Okay, so what is equation 1? That is probability of A given B should be equal to probability of A. So either of these two equations should be satisfied. So then only we say that these two events are, okay, these two events are independent by pair. Okay, so this we have discussed in the last class, and we also discussed this problem. Okay, so in this we have discussed that if two events are mutually exclusive, they cannot be independent. And we also discussed that probability of A intersection B should be equal to probability of A into probability of B. Then we say that two events are mutually independent. Okay, so then we have multiple events. So in the previous case we have discussed that only will be having only two events. Okay, so if we have only two events are involved, independence by pairs is not, if you have more than two events, independent by pairs is not sufficient establish the to establish the events are statistically independent. Okay, so if you use equation 3 will gives that the events are independent only by pairs. Okay, since we have more than two events. Okay, so this equation is not sufficient to check the independence. Okay, so that is why we will be using some more conditions here to check the independence. Okay, so here you see we are taking three events A1, A2, A3, and these events are said to be independent. Okay, only if the, they are independent by pairs and also independent by triples. Okay, so since we have three events, all the events should be independent by pairs as well as triples. That is, they must satisfy the following equations here. What are the equations here? The equations given like this: probability of A1 intersection A2 should be equal to probability of A1 into probability of A2, and probability of A1 intersection A3 should be equal to probability of A1 into probability of A3. Probability of A2 intersection A3 should be equal to probability of A2 into probability of A3. And this is the checking the independence condition by triplet. Okay, so whereas these three conditions are checking the independence by pairs. Okay, and whenever you are taking two pairs, okay, so that should not be repeated. That is, probability of A1 intersection A2 is equal to probability of A2 intersection A1. So again you no need to check probability of A2 intersection A1, only this checking is sufficient. Okay, so whenever you are taking two events, that event, the uh, independent of that event should be checked only once. You no need to repeat more than once. Okay, so these three events are the probability, checking the independence by pairs. Okay, so whereas the last event, last equation gives the checking the independence by triplet. Okay, so here probability of A1 intersection A2 intersection A3 is equal to probability of A1 probability of A2 into probability of A3. Okay, so if these four conditions are satisfied, then we say that these events A1, A2, A3 are independent. Okay, so that is why we have to use, we are, if we have more than two events, we have to check the independence by pairs as well as triples. Okay, so similarly, if you have n events here, for example, if you have n events, okay, so how do we check the independence here? So the independence will be checked by the condition probability of AI intersection AJ should be equal to probability of AI into probability of AJ, where I and J, AI is not equal to J, where I and J values are varying from 1 to n. Okay, so like that we will be checking the independence by pairs by using this equation by taking I and J values varying from 1 to n, where I is not equal to J. Okay, similarly, we have to check the independence by triples. Okay, how do you check the independence by triples? Here, AI intersection AJ intersection AK should be equal to probability of AI into probability of AJ into probability of AK, where I, J, K values are varying from 1 to n, whereas I is not equal to J, J is not equal to K. Okay, so like that we have to form the equations, and these equations are used to check the independence. Okay, so we are checking the independence by pairs by triples, then we have to check the independence by considering four events, okay, then five events, and finally we will be checking the independence by considering all n events, okay. Like that we have to form set of equations here, okay. So so here, what is this? The first equation is we are checking the independence by, this is the checking the independence by pairs. This is the equation by checking the independence by triples. Okay, then we will be checking the independence by considering four events. Okay, then five events, so on. Okay, so then finally we have to check the independence by considering all n events. See here, here we have checked the independence by considering all n events, that is probability of A1 intersection A2 intersection so on A intersection AN is equal to probability of A1, probability of A2 into probability of A3 into so on probability of AN. Okay. So this equation should be satisfied for all the values of ijk, where ijk values are varying from 1 to n. Okay. And here we have discussed that here we have how many events? We have n events. Okay. If you have n events, how many conditions that event should satisfy to check the independence here is 2 power n minus 1. These many number of conditions that event should be satisfied, then only we say that those events are statistically independent. Otherwise, those events are not statistically independent. Okay. So how many number of conditions we have? It is 2 power n minus 1 minus n minus 1. These many number of conditions we have. If these conditions are satisfied, then we say that all the events are statistically independent. Otherwise, the events are not statistically independent. Okay. So if it is satisfying only the statistically independent condition by pairs, then we say that the events are statistically independent by pairs. If all the conditions are satisfied, then we say that all the events are statistically independent. Okay. So here now we discuss the properties of independent events. Okay. So here we will be summarizing the properties here. So in the first property, if you see here, if there are n events, A1, A2, so on, An, or the n independent events, then any one of them is independent of any event formed by the unions, intersections, and complements of others. Okay. For example, you take A1. A1 uh, will be independent of any event that is formed by the union. Okay. For example, A2 union A3. Okay, it is independent of A1 is independent of A2 union A3, and it is also independent of A4 intersection. You take intersection of any two events. Okay. So whichever event you are taking, that will be independent of the other event which is formed by the union here. It is formed by the intersection, and it is also independent of the complement. Okay, complement of other event. Okay, so this is the first property. Okay, take, so for example, then any one of the event, whichever event you are taking, is independent of any event formed by the union, intersection, and complement of others. Okay, so this is our first property. So from the first property, we will be getting all other properties here. For example, you see here in the second property, the second property says that if you have two independent events, so A1 and A2, if you have two independent events, A1 and A2, it results that A1 is independent of the complement of other event, that is A2 complement, and A1 complement is also independent of A2, and A1 complement is independent of A2 complement. Okay. So you take any event that will be independent of the complement of other event. That is A1 is independent of A2 complement, A1 complement is independent of A2, and A1 complement is independent of A2 complement. Okay. And this is our second property. And we'll see the third property. The third property says that if you have three independent events, okay, all these all these events are independent events. So it will satisfy all those four conditions. If three events we have, So these three events should satisfy four conditions. Then only we say that these events are statistically independent. Yes or no? So in here these three events are A1, A2, A3 are independent event. Okay. So then any one of the event if you are taking is independent of joint occurrence of other two. So what is joint occurrence is nothing but intersection. Okay. So A1 is intersection of A2 intersection A3. A1 is intersection of A2 intersection A3. Since these events are independent, this can be written as probability of A1 into probability of A2 intersection A3. Okay, since all these three events are independent, probability of A2 intersection A3 can be written as probability of A2 into probability of A3. So, probability of A1 intersection A2 intersection A3 will be equal to what? Probability of A1 into probability of A2 into probability of A3. Okay, so this is our second property. Okay, so this can be extended to the other events like A2 intersection A1 intersection A3, A3 intersection A1 intersection A2 also. Okay, so this will be true for the other conditions also. What are the other possibilities here? A2 intersection A1 intersection A3, A3 intersection A1 intersection A2. Okay, so because this is the property of independence, it will be satisfied. Okay, and the next property is that, okay, so here you see here, if any one event if you are taking, it is independent of union of other two. This we have already discussed in the first property. The same thing is discussed here. Say if you are taking A1 is independent of A2 union A3. A1 is independent of A2 union A3. Okay, so when the two events are independent, probability of A1 intersection A2 union A3. So this will be in the place of A, this will be in the place of B. So probability of A intersection B can be written as probability of A into probability of B. So in the place of A we have A1, no? So it is probability of A1. In the place of B we have A2 union A3. So it is probability of A2 into A2 union A3. Okay. So these are the four properties of independent event.